All right, it's 6:05 now, so I'll start my presentation. So first of all, hello all, I'm Christopher, a rising ninth grader from New Jersey, and welcome to today's math contest workshop. I'm excited to talk to you guys about various math Olympiads and competitions. These Olympiad workshops are part of a series, and this is the last workshop of the series, as shown here. All right, I'll start by presenting some elementary and middle school math competitions, and then we will talk about some high school competitions as well. So let's start by introducing some elementary and middle school math competitions in New Jersey. In New Jersey, we have three main elementary and middle school math competitions, which are JHMMC, Gauss Math Tournament, and the West Windsor Plainsboro Mathematics Tournament. JHMMC has been held at Bergen County Academies since 2003. Gauss Math Tournament has been held at Gauss Academy since 2013. And West Windsor Plainsboro Mathematics Tournament has been held at WWP South High School since 2013. All right, so next we can talk about MOMS, which stands for Mathematical Olympiads for Elementary and Middle School. MOMS is for students in grades 4 to 8. There are two divisions. Division E is for students in grades 4 to 6, and Division M is for students in grades 6 to 8. Each year, MOMS is composed of 5 contests on different days, and each contest has 5 problems to be solved within 30 minutes. And so that is the format of the MOMS test. All right. Next, let's introduce the Mathworks Math Contest, which is for students in grades 6 to 8, with some restrictions on age, which can be found online. And it's also the qualification exam for the Primary Math World Contest. In MMC, there are 15 problems to be done in 2.5 hours. And again, the top 2 boys and girls qualify for the PMWC, which is the Primary Math World Contest. All right, now let's talk about Math Counts. Math Counts is one of the most well-known middle school math competitions. Students in grades 6 to 8 can take this competition in teams of 4. Math Counts is divided into 4 levels, which are school, chapter, state, and national levels. And a student can advance from a level to a higher one by being a top competitor in the level. So for example, the top 4 in each state can advance to the national level. Typically, the problems get harder from one level to the next. There are 4 tests in each level, which are sprint, target, team, and countdown round. The sprint round is 40 minutes long, and you're given 30 problems to solve. Calculators are not allowed in the sprint round. The target round consists of 4 sets of 2 problems each, and you're given 6 minutes to solve each set of problems, and calculators are allowed. The team round consists of 10 problems to be done in 20 minutes, and again, calculators are allowed. There is also a tiebreaker round for people who tie within the top 10 or so scores in the top 10 or scores in the sprint and target round. So finally, the countdown round is for the top 10 scorers on the sprint and target round. And here are the results of the 2021 Math Counts Nationals. As you can see, the teams in the national round are states. On the other hand, the teams in, say, the chapter round are schools. All right. Now, let's talk about the American Math Competition Series. The American Math Competition Series consists of AMC8, AMC10, AMC12, and AMY. The AMC8 is for students in grades 8 or below, and there is 1 exam per year. In this exam, you get 40 minutes to do 25 multiple choice questions, and the number of correct answers is your score. Some awards you can get are the Honor Roll and Distinguished Honor Roll, and the latter is often referred to as DHR. You can find more information in the link below. All right, let's look at some statistics. All right, so last year the AMCH had 57 perfect scores, and the honor roll cutoff was 18, and the DHR cutoff was 21. You can see the distribution of scores in this diagram. In addition, 1,408 total schools attended the AMCH. All right, here's a sample problem from last year's AMCH. I'll give you all 3 minutes to try this problem, and then I will share my solution. All right, 3 minutes have passed. Please tell me if you need more time, and if not, we can start discussing the solution. All right, so nobody's saying they need more time, so I will start the solution. So we're given rectangles R1 and R2 and squares S1, S2, and S3 shown below. These form a rectangle that is 3322 units wide. Oops, okay, so let's erase this. All right, it's working now. So this is 3322, and this is 2020 units. And so we're given 3 squares, so we can make some variables. So a good variable choice here is the side length of the squares. So we can set A1 to be the side length of square S1. Of S1. So this length over here would be A1. Similarly, we can set A2 to be the side length of S2 and A3 to be the side length of S3. So A2 and A3 are defined similarly. All right, so let's draw these. This is A2 and this is A3. And so now we have 3 variables. We want to find some equations in these variables. So we know that this rectangle that they combine to is 3322 units wide and 2020 units high. So we can use these to create some equations. So for example, we know that this length over here is A1, and we also know that this length over here is A2. And so this length over here is A1 plus A2 because R1 is a rectangle. And also, this length over here is A3. And so what we can see is that this rectangle, sorry about that, this rectangle has width A1, this rectangle has length A1, or sorry, width A1, sorry, hold on a moment. So we can find that the width of this rectangle is A1 plus A2 plus A3. And we know that this is equal to 3322. And similarly, we can find an expression that equals to 2020. We can notice that this length over here is A2, or rather A1 minus A2. So this is A1 sorry, this thing is not letting me write for some reason. So, okay, hopefully it works. If I All right, so it works now. So this length is equal to A1 minus A2 because this total length is A1 and this little length right here is A2. And so we can find that this length is also A1 minus A2. This is because R2 is a rectangle. So the second equation we can write is A1 plus A2 plus A3 is equal to 2020. And now we want to find A2 because we want to find the side length of S2. So let's write these equations in the following way. So we have A1 plus A3 in parentheses, and then minus A2 is equal to 2020. And also A1 plus A3 plus A2 is equal to 3322. And from these two equations, we can actually find A2 because we can regard A1 plus A3 as its own variable x. And while we don't really need this, this helps us kind of visualize how we can find A2. So we have x minus A2 is equal to 2020 and x plus A2 is equal to 3322. All right. And so from these two equations, we can subtract the first from the second to get 2A2 is equal to 1,302. And from here, we can find that A2 is equal to half of that. So what we find is that this is equal to 651, which is answer choice A. I see a lot of you got this answer correct in the chat, so good job if you got it right. Okay. So next, let's move on to the AMC 10. So this is the next competition in the AMC series, and the AMC 10 is for students in grades 10 or below. There are 2 exams per year, and students are eligible for both. This format of the exam is similar to that of the AMC 8, with the exception that you can get 75 minutes to solve the problems instead of 40 minutes. The scoring of this exam is also different from the AMC 8. Now you can get 6 points per correct answer, 1.5 points per blank, and 0 points per incorrect answer. So there is a relative penalty for wrong answers on AMC 10. Some awards you can get are Achievement Honor Roll, Distinguished, and DHR. Furthermore, the 5 top scoring US girls in the AMC 10A will receive the Mariam Rezahani AMC 10A Certificate of Excellence. And now let's see some statistics. On this year's AMC 10A, the DHR cutoff was 132. As you can see here, there were 27 perfect scorers. I'll give you all a moment to digest this information. All right. So also there is the AMC 12, which has the same format and scoring system as the AMC 10. But the AMC 12 is for students in grades 12 or below. Again, there are 25 multiple choice questions to be solved in 75 minutes. Some awards you can get are Honor Roll, Distinguished, and DHR. All right, so on this year's AMC 12A, the DHR cutoff was 133.5, and there were 17 perfect scores. You can also see the student score distribution here on this graph. Okay, so here's a sample problem from this year's AMC 10 and AMC 12. I'll give you all 3 minutes to try this problem, and then I will share my solution.
Excuse me?
Yes?
So they say that Fi and then there's this symbol. What is there's a symbol between Fi and EH, and there's also a symbol between GJ and EH. What's that symbol?
Oh, that symbol means perpendicular to. So
Oh, okay.
we have Fi is perpendicular to EH and GJ is perpendicular to EH. All right, 3 minutes are up. Please speak out if you need more time. If not, then let's talk about the solution. Okay, so more time. All right, I'll give you all 2 more minutes. All right, 2 minutes have passed. So don't worry if you didn't solve this question. It's not trivial, and it actually takes some clever tricks. So let's look at the solution. So we're given a square ABCD, which is divided into 4 parts as shown, and we're given that the area of each part is equal to 1. So the area here is 1, here area here is 1, area here is 1, and the area here is also 1. Okay, so that's a 1. Yeah, there we go. So from here, we can see that the area of ABCD is 4, because we know that the area of the 4 sections are all 1. And so from here, we can find the side length of square ABCD. So we can find that this length over here is equal to 2, because the area of the square is 4. We're also given that AH is equal to AE. So these two lengths are equal. And we're also given that the area of triangle HAE is equal to 1. And so from here, we can see that we can actually find the length of AH. And this is because we see that HAE is actually an isosceles right triangle, because this angle right here is 90 degrees. So we can let the side length be x. And from here, by using area formula, we see that 1/2 x squared is equal to 1. And thus, x is equal to the square root of 2. Note that we can't have x equals negative root 2 because x is a side length, and so it has to be positive. And so from here, we get the length of AE is equal to the square root of 2. And I'll write it here too, so it's on the diagram. But we also know that AB is equal to 2 because it is the side of the square, right? And we found that the side length of the square is equal to 2. So AB is equal to 2. And so from here, we can find the side length, or the length of EB. So EB is just AB minus AE. So this is equal to 2 minus root 2. And now now that we know some lengths, we can look at what we want to find, what we're trying to find. And what we want to find is Fi squared. And so we can find Fi squared by noting that Fi squared sorry about that, I'm having some technical issues. All right, so from here, we can see that since we want to find Fi squared, we can see that Fi squared is simply twice the area of this isosceles right triangle here. So what we did here was we extended CB and HE we extended CB and HE to meet at a point, let's call it X. And so Fi squared is simply twice the area of triangle FIX, because we can see that triangle FIX is a isosceles right triangle. All right, so now it suffices to find the area of triangle FIX. So let's write Fi squared is equal to 2 times the area of FIX. And so we already know that the area of FIEB is equal to 1. So in order to find the area of triangle FIX, it suffices to find the area of triangle EBX. Because we know that we can split FIX into these two polygons. And so the area of triangle FIX is the sum of the areas of these two polygons. So we can write this as 2 times the area of FIEB plus the area of EBX. And again, we know that the area of FIEB is equal to 1. And we also know that the area of EBX is 1/2 times EB squared, because triangle EBX is a 45, 45, 90 triangle. And so the area of EBX is 1/2 times 2 minus the square root of 2, all squared. And now we can just calculate what this is. And at the end, what we get is 8 minus 4 root 2. So yes, B is the correct answer. So good job to anyone who got B as their answer. And that concludes this problem. If you have any questions, please ask. And if not, we can move on to the next slide. All right, let's move on. So people who pass the AMY cutoff on at least one of the 2 competitions they take qualify for the AMY, which is the American Invitational Mathematics Examination. The 4 cutoffs for this year are 103.5 for AMC 10A, 102 for AMC 10B, 91.5 for AMC 12B, and 93 for AMC 12A. The DHR and distinction cutoffs are shown on the right. Here are the dates for the 2021-2022 series. You can find more information about this on the MAA website. All right, so let's talk about the AMY now. The AMY, or American Invitational Mathematical Examination, is for qualifiers. There are 2 exams per year, and qualifiers can take only one of the 2. However, qualifiers can choose which of the 2 they take. In this exam, students get 3 hours to solve 15 questions, and accepted answers range from 000 to 999. In a similar fashion to the AMY cutoffs, people who pass at least one of the USAMO cutoffs are invited to take the USAMO, which is the USA Mathematical Mathematical Olympiad. USAMO cutoffs are calculated as shown. Here are the 8 cutoffs from this year. As you can see, the cutoffs for different combinations of exams are different. Okay, so here's a sample Amy problem. Since this problem is very long, I won't go over it, but I can let you all think about it. So this is the 2020 Amy 1 problem 11. And on the next slide, here is a sketch of the solution. Next, let's talk about the USAMO, which is again for qualifiers. There is 1 exam per year, and it is 2 days long. On each day, you get 4.5 hours to solve 3 problems. Proofs are required for each problem. Scores per problem are between 0 and 7 inclusive and depend on the correctness of the proof. Next, let's talk about MOP. The Mathematical Olympiad Summer Program, abbreviated MOP, is for top finishers on the USAMO and USAJMO. Around 60 people are invited per year, but the exact number varies from year to year. Recently, the camp has been held at CMU and online for the 2020 and 2021. All right, next, let's talk about ARMO. There are 15 people per team at ARMO, and students compete for their region in teams. There are 6 rounds in ARMO, which are team, power, individual, relay, super relay, and tiebreaker. ARMO is held at 5 locations around the United States, as shown. All right, here are some more high school math competitions. They are HMMT, PUMAC, CMIMC, SMT, CHMMC, DMM, and Lehigh Valley Math Contest. You can find all of these competitions online. Next, let's talk about Math Prize for Girls. Math Prize is invitation only for girls in grades 11 or below. There is 1 test per year. Qualifiers must be Amy qualifiers, and there is a cutoff that varies from year to year to qualify. You're given 20 problems to solve in 2.5 hours this exam. Below are some of the awards students can get. Around the top 45 scores in the Math Prize for Girls each year are invited to the Math Prize Olympiad, which consists of 4 problems to be solved in 4 hours. Proofs are necessary for each problem. And here are the top 10 monetary awards, which can vary if there are ties among the top 10. All right, this concludes my presentation of math competitions today. As Lao Tzu said, the journey of 1,000 miles begins with 1 step. This is something very important that we can always keep in mind during our journey through math Olympiads. If you have any questions, you can send them through public chat now, and I will try to answer as many of them as I can. All right, so one question I got in the chat was, can you sign up for math counts without your score? Without your school? I believe that you can't sign up for math counts without your school. Yeah. Okay, so what are some good textbooks? This is a good question. So some good textbooks for AMCH, AMC10, and similar math competitions is AOPS Volume 1 and AOPS Volume 2. These are good books, and in general, the art of problem solving books are really useful and helpful for studying for these math competitions. Okay, so one question I got is, when did you start your math journey? How did you prepare? And what do you find most helpful? So I started my math journey. So first, when I was little, I really liked numbers and number sense, and I found it very interesting. And so, in elementary school, I didn't do much math competitions until around fourth grade, and then I was lucky to come here to Gauss Academy to learn some mathematics, and I found it very interesting and it's very fun too. So that's how I started my math journey. And in the next year, in fifth grade, I went to Lehigh Valley and I went to their ARML team and I got accepted. And there I got to learn that math has a lot of teamwork. And I really enjoy working in teams, uh, working with other people to solve problems and try hard problems together. And so I found this very fun. And so that's how I started my math journey. How did you prepare? Okay, so for the AMC series, I mostly prepared by reading textbooks such as AOPS Volume 2, and I also learned a lot from the Art of Problem Solving Pre-Calculus book. And I found this very helpful because it gave me a solid understanding and foundation of the materials I uh, really had to learn for the AMC 10 and AMC 8. And also, these textbooks are very fun to learn because they have a variety of problems that you can look at. And a lot of these problems are just really fun. They're like puzzles. So if you like puzzles, then uh, I'm sure you'll like reading these textbooks. So what do you find most helpful? So, okay, so I learned a lot from the website artofproblemsolving.com again. And so on artofproblemsolving.com, you can find lots of resources, and also there is a widespread community of people who like math and do these math competitions. And it's really helpful because I can see on the community and also on their wiki, like I can see what other people tried for like certain problems. And it's really fun to see how other people tried these problems because you can see how like other people's perspective on a certain problem. And this is really helpful and also very fun. So yeah. Any other questions? Does AMC 10 and 12 have pre-calc and calc concepts? So I think on the AMC 10 and 12, most of the concepts you need are in pre-calculus or algebra 2. There's not really much beyond that. And similarly for the AMC 12, you don't really need anything beyond pre-calculus. Some of the problems might be easier with calculus concepts, but I don't think you need them to solve any problem. What's the difference between competition math and school math? All right, so I guess the main difference between competition math and school math is that competition math is more like you have a puzzle and you want to like solve it within a time limit, and you have multiple puzzles that you have that you want to solve. And whereas school math is more like you learn things and then you learn how to apply them. And although there's a lot of similarity between school and competition math, I think the main difference is that competition math is more like solving a puzzle, while school math is learning the material and understanding it well. So in my opinion, there is a lot more room for creativity in these competition math problems. And so this is why I really enjoy doing competition math. So that's a great question. Does AMC 10 need pre-calc? Okay, so AMC 10 doesn't really need that much pre-calculus. So like you won't need to know trigonometry for AMC 10. I think actually learning algebra 2 is probably enough for AMC 10. There aren't that many very difficult concepts. Usually the AMC 10 or in AMC 12 want to make problems that don't require that many very difficult concepts, but more like creative thinking and like critical problem solving skills. So it's more about like being clever and making like creative, like using creative problem solving techniques rather than learning a lot of pre-calc. And so like it's more about problem solving abilities than learning a lot of stuff. So yeah, no problem. Any more questions? When should you start taking the AMC competitions? I'd say you can start taking the AMC competitions when you'd like to. There's no, they don't restrict you to start taking the AMC competitions at some particular point. You don't have to like take them if you don't want to. So I guess the best answer I can give to this question is you should start taking AMC competitions when you want to try some new stuff. Then you could take the AMC competitions. So yeah. Did you take classes? Yes, I did take classes. When I started, I took classes at the incubator here at Gauss Math, or at Gauss Math in New Jersey, and I learned a lot when I when I went to the incubator class, and I felt that that was a very good way for me to improve because I learned a lot of ways I could solve problems on the AMC and Amy, and it was also very fun because you don't know these techniques until you learn them. So when I learned them, I found that these techniques are really cool. And so that's, I guess, how I started to do better on competitions. And yeah, so yes, I did take classes. All right, any more questions? How much time did you spend each week when you were in incubator classes? Oh, okay. So I guess I spent as much time I uh I really kind of wanted to because I wanted to solve these problems uh and like understand these solutions. So I did spend some time each week. So like on average, I would spend around or at least 2 hours per week. And so it doesn't take that much time. If you want to, of course, you can always spend more time. All right, so are AMC problems more convoluted than regular school curriculum math concepts? I wouldn't say they're more convoluted. I would just, I'd say they're more like using using concepts that you could learn in school curriculum math in clever ways and just like trying things. Like there's a lot of trying new things and being creative and AMC doing AMC problems. So they're not necessarily more convoluted than regular school curriculum math concepts, but I'd say they probably will take more creative thinking to solve. Okay, so when you are stuck with a question, how long would you keep working at it? Mm, so when I'm stuck with a question, um, usually I would read the solution and see how I try to like see how I could have thought of the solution. And so usually if the problem is meant to be solved in 10 minutes and I don't solve it within 30 minutes, I would go and read the solution because then I won't spend too much time on it. But if there's a problem and I'm stuck on it and there's no solution, then I would keep working at it until I find a way to do it or put it off and then try like uh, try to solve it later. So yeah. No problem. All right, if there are no more questions, I'll move on. So this is the last workshop in our LogiStem Olympiad series. Our math division has prepared 15 fun math workshops, which can be found on our website. The first of these workshops is tomorrow, so please feel free to join. So thank you all for listening to this presentation. And this is the end of the presentation. So thank you all.